appreciate all of your attention. Like Rick said, I'm from Branch Technology. My name is Bruce Hilbert. And I often say I work for a large-scale 3D printing company. And by that I mean we 3D print large things. And that is exactly what we do, mostly for architecture, art installations, that sort of thing. So I'm going to go through this pretty quickly because I have a ton of pretty pictures to show. No technical information, so it's nice for after the snack. But we kind of have a problem in one of our largest American industries, the building industry. It is extremely inefficient. According to an NSF study a couple of years ago, you get $30 billion in wasted material, $73 billion in wasted labor. Customization, if you want anything but a box, your cost goes up by an order of magnitude. And even though we have all of these wonderful digital tools to design things, well, if you've designed anything but a box, you're kind of out of luck. And there's no way to transfer that digital information to the construction site. So my boss is an architect, and he is very inspired by natural structures. And if you think about the way things work in nature, there are no boxes in nature. Nobody builds a box. Material is at a premium, so things are built for strength and resilience and efficiency, and there's lots of variety. What does that have to do with us? Well, that's a mesh. So my boss had the idea, if I could construct a mesh, maybe I can make a building out of it. And so we figured out how to do that. We can print that. We can print a mesh. There is an example of that out on the table outside. You're welcome to pick it up and play with it. Don't run off with it. John will shoot you. But this is how we do it. We have a large industrial scale robot that is an off-the-shelf robot, but the mechanism on the end is our proprietary technology, and it can print structures like that. There's another shot. We now have 4 robots at one facility and 4 at another, and we just ordered 5 more. So we have the capacity to make a lot of very large things now. And this is what it looks like. This is sped up. We wish it went this fast. The important part is you will see right there, it is printing the plastic literally into the middle of the air. So the plastic solidifies as it comes out of the end of the nozzle, and we are able to create our mesh-like structures. You can see me running around in there somewhere. Well, how am I going to make a wall out of that? Well, the idea is you make the prefabricated frame, you fill it up with familiar materials, spray foam, concrete, whatever, and so you create this custom composite. It looks like this. That green, or not green, that orange stuff, I'm pretty sure is great stuff from Home Depot. So, but if you have your house insulated, or you've seen a building being insulated with spray foam, that is essentially what it is. It is the same sort of formulation. It's a closed cell expanding foam. Has a tremendous R value, has a tremendous insulation value. Our stuff is pretty strong. It is not brittle. It is a large truss structure, so it hangs together pretty well. But to accomplish this, you require an enormous amount of interacting technology, robotics, material science, building science, hardware. But none of that is my job. My job is the software. And how did I come to that? Well, just a brief story. The young man you saw standing on the beam is the co-founder of the company, and he had developed a way to get the robot to follow this pattern and print the plastic. And I remember sitting down with him when I was a consultant there, and he said, well, I take and I make sure I have, some number of points this way, and then I have some number of points this way, and so that makes me a little kind of a crosshatch grid, and then I just carry that up through the part, and so I always know where I am in space. And I said, you are creating a structured grid. That problem has been solved for 30 years. Let me show you. And I opened up Pointwise, and I had 5 clicks and made a structured grid for him. And they just went, oh, you can do that. Yeah, I can do that. So we went on, and I have done many, many projects. And I have made them all in Pointwise. So that's what I'm going to show you today, all these things that have been made with Pointwise. Quickly, this is a project that went into the Museum of Art and the Museum of Design in Atlanta. It was designed by the same gentleman who designed, along with his wife, the 9/11 memorial at the Pentagon. And that is the blocking structure for the top. I don't think they would have been able to figure it out unless I had blocked it for them in Pointwise. Because he had got up through the legs with his ad hoc technique and then had no idea what to do. And I said, well, I can just make you different blocks. You can split it up? Yeah, I can split it up. So as far as I know, that was the very first thing ever made with, physical thing made with Pointwise. This was our second project. It's a map of the Tennessee River Gorge. This is a project that went into Cheekwood Gardens in Nashville that 2 years ago we won the Meshy Award with this. I really do like this representation because it shows you what is happening. You have a geometry, not CAD. You make a grid, and then you make the thing. And that is the way the process works. Keith Caseman also said, hey, can I make this weird shape? And I said, I don't know how to do that. I'm going to have to figure this out. But obviously we did. That is University of Tennessee orange, not University of Texas orange. So it still sits in Knoxville. You can see it if you're driving up 75, I think. But the important thing is, and what we care about here, is this is how it got made in Pointwise, just like you would make anything else. I had a geometry. I put a multi-block grid in it. But I had to figure out how to deal with the fact that the legs were one width at the top and a shorter width at the bottom. And we have a printing limit of between about 40 and 80 millimeters on our segment lengths. So if I chose one length at the top, it was the wrong one at the bottom, and vice versa. Like, how am I going to do this? So I said, well, what if I don't have to make the points match up? What if I can get rid of points as I go along the volume? Because this would actually be printed upside down from the way you're viewing it, so it doesn't matter. As long as the robot has a place to land, it doesn't matter if it doesn't land at every point that was below it. That's fine. And this was the first time we did something called transition blocking, and it turned out to be vital. Like most of the rest of the projects we have ever done, we could not have gotten done unless I just ad hoc came up with this. Which is, by the way, nothing you would ever do or in a CFD solver. I mean, you might, you do this eye blanking kind of stuff, but you would not, unless you had a very specific application, you wouldn't throw away points for no reason, because you don't have the same kind of spacing requirements that we do. We thought for a while we would make our living with furniture, and even designed and printed a lot. That didn't work out. Although it did give us an opportunity to investigate printing with other materials, which I can talk about if I have time. But that little table is actually a biopolymer. I think that's made from sugarcane. We also once tried to print something made from swamp algae. It smelled pretty bad when we printed it. I think somebody, it was like a flaming diaper was the way somebody described it. So we didn't go down that road. We decided there were other things. But one of the things that I really learned from the furniture was to do a multi-block setup. If I'm on an industrial scale where we don't have to make the individual blocks and stick them together afterwards, it's really important to get the orientations of the block correct so that I can print this block, which gives me that edge, and then as I print this block, that edge is there and I just have to omit it from the program. So that sequencing also became something very important later. We did a little shelf. It's honestly not very interesting. People ask, well, can you print this? Can you print that? Can you print this? And the answer is likely yes. We have printed a wing. I have no idea what kind of wing that is supposed to be. It was designed by an architect, so it probably wouldn't generate much lift, but that one would. We had an Air Force general coming through, and I said, he'll know what this is. And so I made a mesh on an Onera M6 that I had lying around, and he did know what it was. So that was nice. I talked about most of that the last time I was here, but this I could not talk about. In fact, we were working on it 2 years ago when I was giving a presentation here, and my boss was yelling at me for going out of town and calling me, I need this, I need that. But this is the project that really launched the company, to be honest with you. This is what has generated all of our buzz. A design firm called Shop, which is a design firm out of New York, said, hey, we're going to make this pavilion thing for a design exposition in Miami. Can you do it? And we said, well, we don't have the capacity, but we'll gear up. And we did manage. So we got this design. One of the pavilions, it's got something on the order of 20 parts. We had to part it up. You can see they get really big. That's what it looks like. That's what the geometry looked like in Pointwise. And fortunately, it had a lot of both mirror and rotational symmetry, so I didn't have to grid the whole thing. But this is huge in terms of what we normally do. But it turned out pretty well. It worked. And if you look carefully, you might not be able to see, but if you look carefully, you can see where a connector was. I can look at our stuff and pick out, I put a connector there, I put a connector there, The other parts were actually printed, the lighter brown parts were actually printed by Oak Ridge National Lab as part of it, as part of the project. But this is a very nice shot of the whole thing. It seems to be jumpy. One of the shop guys took a drone down to the install and flew it around, and we just thought, well, this is great. Well, No, let me. You all right? Well, this was a conference of designers, so you had all adults around it. And I'm sorry it's a little jumpy. I think it's the computer. But what I will tell you is that part of the contract was this was here, and then it was at this design exposition, and then it was moved to an upscale kind of mall area. And the contract said it had to be taken down if the winds were predicted to be higher than 60 miles an hour. They didn't, and it has been through 2 hurricanes, and it is just fine. So I'm kind of proud of that. I'm like, hey, it didn't fall down.
But is it kid-proof?
No, it is not kid-proof. This is a shelf we made in, not a shelf, it's a bench we made in collaboration with MIT. And the important part here is that they took our grid structure from a basic form and they did some fancy FEM and modified it to improve the stiffness. So they gave us back our grid, which was great. Except they really didn't. They just gave me back a whole bunch of points and edges. I'm like, this is not a grid. There's no connectivity here. What am I going to do? Well, I'm going to make it by hand and make sure it lines up with everything they told me, which I was able to do in Pointwise. And I did pretty good. So we were able to print that, put spray foam in it, and then mill it down. That's always the fun picture to show. And wait a minute, I went too fast. So it worked out quite well. We actually had a surfboard guy who works for us now give it that white finish. Okay. Next big project, something called Nature Cloud. This was a project we were approached about to put in the Natural Museum of History in Chicago. And they said they wanted to have these hanging plants. They had a French designer. They said, can you print something like this? Yeah, we can do this. Do you have a design? Yes, we have a design. So this is the prototype. It's a lot of hanging grid. Winds up looking like this, what you put the plants and the cute purple lights in it. They were happy with the prototypes, and they said, here, make 4 of them and make one of them really big. Okay, we can do that. That is the geometry for the cloud we called stratus. This one is the big one, and it is designed to be lowered down, as you saw it there on the ground, so that you could actually have some sort of a reception inside of it. That was the idea, so that when their big donors come, they'll lower it down and they'll have a cocktail party inside this big plant. That's the grid. And if you think you get bad geometry, the geometry I get is terrible. You can see this is one piece, and it does not in any way connect with the pieces around it. I have geometry inside of geometry. Okay. I can't fix it, so we just grid over it and make it look right. This geometry actually turned out to be not too bad because I could copy and paste a lot. But I wound up having to go back to a technique I had developed before in the transition blocking, like I told you about before, where you can see that the points don't match. I've got 2 cells here and 1 cell next to it. Because that was the only way to grid that distance and that distance. You can't do it any other way. And it became really difficult to find the blocking structure to say, all right, I got to print this one, 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 this one. So we wrote a script so that I could pick them in order and know what I had picked, and then write them out appropriately so that we could send it on to our path planning software and then to the robot. It worked. We made 4 large clouds, and they were very happy with them. We recently had a friend of ours go through the museum and say, they look great. So yes, you have another mesh in a museum. That is not a misspelling. That was our same big project we were doing while we did Nature Cloud. It is a development in Nashville that is mixed use. It has high-rises with retail and residential and office space and those sorts of things. And they had a quadrangle where they wanted a band shell. So they came to us because they had seen the Miami Pavilion and said, can you build us something like this? I said, sure. So we sent it to the engineer and decided to do a form study. So they took the form and we optimized and we optimized and we optimized. And we optimized a lot. We went back and forth forever. And finally came up with this shape that would support itself without having to have all that material in the middle. So it doesn't have to be a dome. You can take out all that material and everything is just fine. And I'm going to run out of... So there is the geometry in Pointwise. And that is the grid. This is almost 1,000 cubic feet of printing. It's huge. And there it is in Nashville. You can see the Microsoft building if you stand under it. And that's just to give you a sense of scale because, well, there's a man standing up. So it's huge. It's overwhelming to stand under. And we made a nice video. This was for, and you'll have to forgive the hyperbole, but an architect made this. This was made for a conference called IASS, I think it's International Association of Shell Structures. And they had a contest about the best shell structure, and this was analyzed as a shell structure, so they wanted us to enter. That's the fun part. Yes, we had to print things sideways. Like I said, hyperbole. I'm in there somewhere. All right. So I'm going to run out of time, and I don't want to push it too much, but I do want to talk again about software. I will quickly quickly blow through the fact that I realized when I did this project that the process we have, doing it in a structured grid, it's way too prone to human error. Because I have to create these transition blocks all over the place. And once I have picked where one is, I'm stuck. I can't move it around without tearing the whole grid apart. So if I choose poorly, I'm in trouble. And time is often of the essence because we're often trying to keep up with the robots. So I did write a few scripts, or I had my colleague Philip write a few scripts actually, that allowed us to move the points, distribute them appropriately in the middle, and then I could split blocks, and I would have two nice, this is a 40 millimeter segment and this is a 40 millimeter segment, and so the whole thing winds up being 80 and we can print that way. That was the point. and I'm going to skip through this, but we did wind up in Rhino writing our own. It is a mesh generator, but it's really more of a mesh helper than it is anything else, because this first part, one of our guys wrote a way to block things, but I wind up blocking things in Pointwise in the beginning, quite frankly, and then bringing it into here to do smoothing. Let me see if I can skip ahead. There we go. So you will see the red segments mean they're too long, and so we will wind up adding things. Can add a slice, do a whole bunch of stuff. I want to see it. You can watch it. Watch the points move. You can see how it's smoothing the grid. We are smoothing this grid with basically the same technology that Steve is using to smooth things in Pointwise to create the higher order meshes. Guess who my advisor was? So it doesn't matter, and this is the brilliant part, or this is the part that we absolutely had to have. It doesn't matter where you add the points. Once you hit the smoother, everything can move around and we can be fine. And that can work across blocks and is a very, very specialized tool so that we can make sure we have, okay, everything's greater than 40, everything's less than 80, we can print this. And I want to go real quick because in the future, I don't want to make structured grids anymore. Really and truly, I don't want to make structured grids anymore. So how am I going to do an unstructured grid? Well, I'm going to make one in Pointwise. That is nothing but a tetrahedral grid. It's very, very simple. I've just ensured that all my segments are greater than 40 millimeters and less than 80 on the correct scale, and we're fine. Well, now what do? How do I tell the robot to print this? Because the reason we use structured grids is that we exploit the pattern. We always know which way to walk. I'm here, I'm going to go to here, I'm going to go to here, I'm going to go to here, I'm going to come back, I'm going to hit these points. I'm exploiting the pattern. Well, there's no pattern by definition. Well, got an idea. Come on, play. There we go. So you'll see the blue is the print order. So this is a completely reasonable order in which the robot could print this mesh structure, and we have assured that at every point, after every segment is printed, it still stands up and nothing falls over, so that you always know if I said this point was in my mesh and I want to come back to it, it will be there when I want to land on it later. Believe it or not, we finished this probably a year and 3 months ago, and then we had all these projects, and so, all right, well, I can't work on this anymore. We'll go work on, making money. But this is our future. I see that by the time the next user group meeting rolls around, I will be talking about, I opened Steve Carman's AutoMesh script and clicked, and then I had an unstructured grid, and then I took all those parts and I sequenced them with this technology. And that's what you see printed. Come on. Okay. All right, I am out of time, but if Rick will allow us to entertain a question or two.